Hi all. In this session, we discuss about syntax directed definitions, simply call it as SDD, and syntax directed translation, simply call it as SDT. So both comes in semantic analysis phase of the compiler, which is the third phase of the compiler. Next to the parsing, we have a semantic analysis mainly used for type checking. And it uses the syntax tree and informations in the simple table to check the source program for semantic consistency with the language definition. So in the semantic analysis, the syntax directed definitions means each productions variable has attributes with semantic rules associated with each productions. So each variable has extra attribute and semantic rules associated with each productions. So you take some example. E tends to E1 plus T. Here this E1 we are differentiating with the head, and E1 dot val tends to E1 dot val plus T dot val. This is attributes. Dot val is the attribute. So next example is, for example, take the declarative statements. D tends to TL. Here T represents a type and L represents a list of identifiers. Here we can represent this by attributes, that is L dot in equal to T dot type. This we will discuss elaborately later. What is SDT? SDT is, it has a semantic action within production bodies. That is a small fragments of code along with your productions. So here the semantic actions is enclosed within calibrators. For example, E tends to E1 plus T. Here the what action it is taking place, that is print plus concatenate. If it is a string, concatenate two strings. If it is a numbers, concatenate that is add two numbers. So syntax directed definitions is a specifications and a syntax directed translation is a implementations. We use the syntax directed translations for generating a 3 address code that we'll discuss later. So in the semantic analysis, as we discussed in the previous slides, SDD, that is syntax directed definitions, and SDT. SDD is the value of attributes by associating semantic rules within the productions. That is, simply we call it as context-free grammar plus semantic rule is SDD. What is syntax directed translation scheme? Is embeds program fragment called semantic action within production bodies. SDD is easier to read and easy for specifications. Here the implementation is hidden and what is happening inside is hidden. Yes, evaluations, the way how it is evaluating is done by SDT. SDT can be more efficient, easy for implementation. That is, SDT are more efficient than SDDs as they indicate the order of evaluation of semantic actions, how the order of evaluations occurring of semantic actions associated within your production rules. So this order of evaluations we'll discuss in the later slides. So this is the elaborated one of SDD, syntax directed definitions. As discussed before, it's a context-free grammar together with attributes and rules. What is attributes? Attributes are any values, or it may be a names, or it may be a code, address, place. All these are attributes, and it is after it is along with each variables of production. After dot its value, dot e dot val, e dot code. And rules is what rules, what is the action taken place. Attributes are associated with the grammar symbols, rules are associated with productions. Here the expression dot trans, here expression is a non-terminal which is a variable, and trans is an attribute, has a name and a value, maybe a name or a value. This is SDT. So SDT is the rules or program fragments to production in the grammar. So SDD, as we discussed earlier, SDD is a E1 tends to E2 plus T. Its meaning, this is a production meaning, semantic rule, E1 dot code equal to E2 dot code and T dot code. As I said, no, what is that code? Code is a attribute, and which is attribute means it is coming, it is along with the symbol with a dot, and a plus is the, what is plus? This is going to add if it is a number. What is SDT? The same thing, it's a semantic actions, printing action taken place. Here F tends to ID. F tends to ID is, what is our ID value? ID has some value, identifier has some value which is going to print that value. So semantic action taken place in this SDT, and here the attributes as well as the rules adding, or what the rule is given, it is in the SDD. So these are the some SDD versus SDT scheme for infix to postfix translation. So this is SDT scheme and this is SDD. SDT means, as I said before, there is a semantic actions embedded within a program, embedded within a productions. What is this action? E tends to E plus T means print plus. E tends to E minus T is subtract to value. And T tends to 0 means it's a print to 0. T tends to 1 means it's a print to 1. T tends to 9 means it's print 9. What is SDD? Is a definitions. Here it is not showing the what is the action taken place, it's just shows the meaning, semantic rules. The rules should be showing here, shown here. That is the same productions as it in SDT. E tends to E plus T, E tends to E minus T. So what is this SDD? E dot code equal to E1 dot code or T1 dot code plus. So this is, and what is T tends to 0? T dot code equal to 0. So what action is hidden here? Here the action is explicitly shown. Here only rules given. The rules given are, what is that code represents? The code represents is some action is done inside, to be done inside. Okay, this is just for example for differentiating what is SDD and SDT. We need not to confuse with the SDD and SDT. Commonly we can say everything is SDT to generate a 3 address code, and SDT is mainly for showing the 3 address code, the way, the approach to show the 3 address code. We are using SDT. Now SDT attributes. Attributes are numbers, types, table, references or strings or for instances. So as we know, what is attributes? It is coming in grammar symbol after dot. It may be any value that it may be a numbers, or it may be a type, or it's a table or references. All these are called attributes. That is, additional information, that is attributes, are appended to one or more of its non-terminal in order to provide context-sensitive informations. Each attribute has well-defined domain of values such as integer, float, character, string and expressions. Because as we know, the semantic analysis phase only, we are checking the type. That is, whether it is a integer type, whether the operand is in a floating real or it's a character. So those are comes in attributes. We are representing those by attributes along with the grammar symbol. So attribute grammar can pass values or information among the nodes of a tree. For example, if we take E tends to E plus T, here this E dot value, this is a head and this is the body of the productions. We can differentiate it with E1 and this is E. So if you add these two, E1 E dot val plus T dot val, after getting this resultant, we are storing this result into E dot value, that is the head. Here The semantic attributes may be assigned to their values from their domain at the time of parsing and evaluated at the time of assignment or conditions. So there are two types of attributes here. One is synthesis attributes and inherited attributes. Its value is taken from its children and itself in any node in the tree, and the grammar symbols takes its value either from its children or itself. What is inherited attributes? As we know what is inherited, the children inherited the properties from the parent. The same thing here. The nodes, it means each symbol in the parse tree, we call it as a node if it is a tree. So grammar symbol, the node's parent which is inherited from the parent and itself as well as the siblings. Then this is inherited attributes. The attributed values get from its parent node and itself, then siblings, that is inherited attributes. So we have two types, that is synthesis attributes and inherited attributes. So the example of this synthesis attributes. So as we discussed earlier, what is synthesis attributes we know. The synthesis attributes means if we evaluate a child node, then only we get the parent node value. That is the synthesis attributes, which means take this production S tends to A, B, C. These are the child nodes. After evaluating the child nodes A, B, C, these resultant value only stored in S. So what is S dot value? S dot values depends upon its child nodes. That is, the synthesis attributes is depends upon its child nodes. What is inherited attributes? Inherited attributes is the S values depends upon its, which means if you take B, the B may depends upon its siblings or it may be a parents. S tends to A, B, C. Take this production, S tends to A, B, C. So here, what is that? The values, the C may take its value from A, B as well as S, which means A and B are siblings of C and its parent. So the value of C, how we are evaluating value of C? From its parent as well as the siblings. There is one example here. See this production. The productions is D tends to TL. This is a simple type SDD. SDD for simple type declarations. So D is a declaration, T is a type, L is a list of identifiers. Here T represents either integer or floating point and L represents identifiers. So what is the semantic rules given here? This is SDD. Now there is a semantic rules here. So L dot in equal to T dot type. What is in represent? In is a inherited attributes. What is a type? Type is a synthesized attribute. Here we can have, in the productions, we can have inherited attributes as well as a synthesized attributes. So, or otherwise only synthesized attributes in the productions. The attributes may have. But here in this example, we have both inherited attributes as well as a synthesized attributes. So what is it? L dot in. L dot inherited attributes, and which is inherited, this L is a list of identifier which takes value from T. T is a type. If it is integer, then identifier is an integer. Then if it is a float, the identifier which is present in L list of identifier is a float or real. What is this type? Type dot integer. T dot type is an integer. This is synthesis because this is an integer. Integer where we are getting from the, that is T is getting from, T is a head node and parent. It is getting it from the child node because we have declared this as an integer. Then these are some representations of the tree structure. Parse tree, what is parse tree, what is syntax tree, what is annotated parse tree. How to construct a syntax tree, we will discuss it elaborately later. Now just if we see these examples of the structure of these trees. This is syntax trees. We have the, we know what is syntax tree because always the parent should be a operator and the children are the numbers. And what is a parse tree? Parse tree is This is a construction of the parse tree. We have to construct parse tree with the grammar symbols. E tends to E plus T, E tends to T star F, T tends to F, F may be a digit, F is a digit. Okay, this is a parse tree. What is annotated parse tree? Annotated parse tree is, it has a value, it has an attribute along with each grammar symbol. E dot val is an attribute which represent maybe a numerical values. E dot val is a numerical value. T dot val, F dot val, and F dot val is a digit dot lex value. Lex value means the lexical analyzer gives a value to the this phase, that is semantic phase. This is called annotated parse tree. Annotated parse tree is when we say the annotated parse tree, the grammar symbols along with its attributes and its values is called an annotated parse tree. So a parse tree showing the values of attributes of each node is called an annotated parse tree. So the process of computing the attributes value at the node is called annotating or decorating of the parse tree. So we can call this as a decorating. Annotated parse tree is also called decorating of the parse tree. So now let us discuss one example of SDD. This is SDD of a simple disk calculator. Simple calculator will do addition, subtractions and multiplications. Here we have two expressions, that is a plus and multiplications. This is SDD for a disk calculator. Since it is SDD, it has a attribute values, which means a value attribute with each grammar symbols, along with each grammar symbol, and there is a semantic rules. This is a productions, given production. L tends to En. What is this N? N is an end marker, and this SDD is also called a bottom up, and it will be the it is also an example of synthesized attributes. This is a simple disk calculator. L tends to E, which means our language or statement has a expressions, some final value which has, after done all the expressions, after done all the calculations, we are getting the final result, which represent end marker. This is a end marker. We can say this is a end marker. End marker. So here another example is E tends to, another production is E tends to E1 plus T. This is production number 2. This E and this right hand side of the productions E1, and this is left hand side of the production E. This represents the parent and this represents a child node. To different distinguishing, we have a E1. Then E tends to T. To distinguish parent and child, we have the E and E1. E tends to T. T tends to T1 star F. T tends to F. F tends to E, and F tends to digit. So how the semantic rules look like? Since it has a value, numerical value, we can have val as an attribute. So L dot val equal to E dot val. Assign this value to the L dot val. After getting computing, after done the computations, we have to assign the result to the L dot val. What is E dot val? E dot val is equal to E1 dot val plus T dot val. So adding two values present in this variable, that is the grammar symbols, context free grammar, E1 T. This E1 dot value equal to T dot value, and T dot value equal, which means we have we are assigning the value here. So what is it? F dot val. F dot value equal to digit dot lex value. This is the core value. This is the final. This is the value digit which is getting from the lexical phase. Lexical, that is lexical analyzer supplies digit to this grammar, this symbol F dot val. So this is the for this SDD, for a simple disk calculator, we have annotated parse tree, because we have to evaluate these productions using parse tree only, annotated parse tree. And as I said before, this is a bottom-up approach. We can say this is mainly for a bottom-up approach, and this is one of the example of a synthesis attributes. We can for synthesis attribute we can write SDD disk calculator, SDD for a simple disk calculator. So how it is working, how we are evaluating this one, represents annotated parse tree, And for that we have taken one example, 3 into 5 plus 4. N is a n marker. With that the expressions wins. So first thing is, we have, since it is a bottom-up approach and it is a synthesis attributes, the head, the parent node depends, the parent node value depends upon its child node value. First we have to take this, the seventh productions. What is the seventh productions? What is its meaning? F dot val equal digit dot lex val. We have to represent this semantic rules by digit. If it is a value directly assigning, means we should represent it by digit dot lex val. So digit dot lex val equal to the first one, the 3. We have to scan from left to right the 3. That the 3, that which is supplied by the lexical analyzer. That the 3 should be assigned to this f dot val, since we know that f dot val is equal to 3. Then what is this? Actually, this f dot value here come to the production number 5. This is production number 5. This one is production number 5. Come to this production number 5. So what is this value? F dot values we are assigning to t dot value. So what is f dot value? 3. That should be assigned to t dot value. Now come to production number 4. What is production number 4? T tends to, which means t dot value equal to t1 dot value into f dot val. This is a child node, so this is t1 dot val. For differentiating we have given here, but here we need not to represent because this is a child node. So t dot val equal to 3 star. Now what we have to do? We have another production. According to this expression, we have drawn the annotated parse tree. So we have to read the another value because it has another value of dot val. Okay, in this case we have to supply the, that is lexical analyzer, supply the value 5. So 3 into 5, that is t dot val star f dot val 5 equal to t dot val. This is fourth productions. So we have to multiply it. 3 into 5. So 3 5s are 15 should be assigned here, and this t dot val, which is according to the rule number 3, production number 3, this 15 should be assigned to e dot val. And next one is, we have the e dot val equal to t1 dot val plus t dot val. For that it requires, we have another number and values, that is 4, that should be assigned to f dot val. F dot val is, because f dot val is directly taking the digits, then that should be assigned to t dot val. Here we have to add 15 plus 4 according to the production number 2, and it should be assigned to the root 19. Then this e dot, according to rule number production number 1 and the semantic rules, the 19 should be assigned to L dot val equal to 19. So the annotated parse tree has the attribute along with its value, and this n represents a n marker. With that the statement is completed. Next is this is another example. We'll discuss one more example. This is one of the example of inherited attributes. What is inherited attributes? Inherited attributes is the nodes takes its value from its parent and itself as well as the siblings. That is inherited attributes. We can also say this is a top-down approach process. So this is the productions. T tends to f t dash. This we can call this as a prefix format. T tends to f t dash. T dash tends to star f t 1 dash. T dash tends to epsilon. F tends to digit. This is a production given. For this production there is a semantic rules. SDD. This is SDD, semantic rules. The semantic rules is how they have written. T dash dot, which means this t dash dot inherent equal to f dot value, which means the values which is present in this what is it? What is inherited? Inherited means it's a parent or a siblings. Okay, so it's a sibling value. It is inherited the value, this value from its sibling. And t dot value equal to t1 dot synthesis. What is t1 dot synthesis? It is taking the value from its child node, and this is a siblings. Here t dash tends to star f t, which means here we are multiplying two numbers. We are going to multiply two numbers. Here t1, this is for differentiation. This one actually t1 dash dot inherit equal to t dash dot inherit into f dot value, which is the siblings as well as its parent, and t dash dot synthesis equal to t1 dash dot synthesis is its gets value from its child node. And here this is a t dash, it's tends to epsilon, means we are assigning directly to the synthesis, which is the value of a t dash is assigned to t, that is another parent node, and f tends to digit. This is the value getting from the lexical analysis. So we have how it is working. This we'll discuss later. See here, this is how we have annotated parse tree, which means this is the expression 3 into 5. Draw annotated parse tree for this 3 into 5 means according to the productions we have drawn here. So how the values is evaluating here. This is how we have to draw. First is t1 dot val, we don't know initially. So then what is that f dot val, and because we have a child node of this f dot val, and this is there is a t dot val, again t dot val is assigned to t1 dot inherit, t1 dot synthesis we need t dash, not a t1, t dash, and digit dot lex value, this we have to get it in the how we are getting means first we have to assign the value 3 from, we have to scan from left to right, 3 into 5. So this 3 lex value, we call this as a lex value because lexical analyzer gives us value which is entered into the symbol table. Digit dot lex value equal to 3, that should be assigned to f dot val 3 according to this rule number 4. Then here t1 dot inherit equal to 3. This 3 should be, because this what is inherit represents? Inherit represents taking the value from the siblings. What is t1? Who is the t1 sibling? F dot val is a t1 siblings. So that a 3 is assigned to t1 dot inherit, and afterwards the t1 dot inherit is assigned to is assigned here. Now we know as t dash dot synthesis, we need to calculate t1 dash synthesis because it has to get its value from the from its child nodes. So here we can say that is the next is according to the production 2. The production is next is star because we assigned the 3 and the next is star f dot value, here f dot value, and t1 this production, take this productions as well as its semantic rules, we have to assign it here, star f dot val and t1 dash dot inherit and t1 dash dot synthesis, because all these grammar symbols we need. So what is f dot val? Directly we have to assign this 5 to the f dot val. Then we have to we should compute this 5 into 3. The 5 into 3 is how we are computing, means here in the inheritant already it has a 3 value, and it is taking another value, that is into multiplications 5, and that 5 should be that is 15 should be assigned in the t1 inherit. And t1 inherit is again we have to give it to t1 dash t dash synthesis, that we can say this is t1 dash, which is assigned here, that is 15. That 15 again assigned to its parent, and this values is again assigned to the t dot val, that is because t dot val is assigned at t1 dot synthesis. So t dot val, this is how we are calculating 3 into 5 is 15, that is assigned here. This is one of the good example for inherited attributes. Yes, attributed SDT means if an SDT uses only synthesized attribute, it is called as attributed SDT, which means the syntax direct translation uses using only synthesized attributes, which means it depends only upon its child node. The parent node depends upon its child node, that is a SDT. We call this as in SDT we call this as a S attributed SDT. What is L attributed SDT? This forms of SDT uses both. SDT means syntax director translations along with the semantic actions embodied in the program production itself. Uses both synthesized and inherited attributes with restriction of not taking values from right sibling. Which means here in L attributed, it has both the synthesized as well as inherited attributes, but all values in the inherited attributes, it is not taking values from its right sibling, only from its left sibling, that is left to right scan, left to right, that is left to right, left to right, left to right, right. So here this L attribute SDT, a non-terminal can get values from its parent, child and sibling nodes, but it should not take values from its right sibling, only from the left sibling. So this is the diagram for S attributed SDT and L attributed SDT, because L attributed SDT both has the synthesis as inherited attributes. SDD for simple type declarations. This is another example for SDD. How we are writing the SDD for type declarations. Here the first protections D tends to TL. D is a declaration and T is a type, L is a list of identifiers. The semantic rules. SDD means it has inherent attributes as well as rules. Here L dot inherit equal to T dot type. What is L dot means list of identifier. It inherits its a type from T. So that is it's a sibling. So all the type we declare here, we are assigning here is a that identifiers takes the type. Int, if it is int A comma B comma C is a declaration statement. Int means int A, int B, int C. The list of identifiers takes the value. So this is the inherited attributes. So it takes value from the siblings. Then T tends to, we know what is inherited. Inherit means it's a value from siblings itself as well as a parent node. T is a different type. It is a int type or float type. L represents L1 comma fourth protection, L1 comma ID. L1 is a list of identifiers which is separated by comma. The meaning of this semantic rules of this is, since it's a list of identifiers, we have a function called add type. It should be entered into the symbol table. The whatever the identifier here, it should be entered into the symbol table. A means A enter into symbol table and type enter into the symbol table. So it has a two arguments, id dot entry, L dot inherit. Add type and L tends to id. Add type id, if id dot entry into the symbol table, whatever the identifier, and L dot inherit is a type. So this is the tree for the parse tree for this SDD. D simple type declarations. So D is a parent node and its child nodes are T and L. D is a parent, child is T and L. So we have to draw it from left to right. T and L. What is a T? T may be int or float or L. And what is L? L represents a list of identifiers separated by commas. So here L dot in equal to ID1, comma ID2, comma ID3. So this is the dependency graph for simple type declarations. Take one example, float ID1, comma ID2, comma ID3. For this, how we have drawn this annotated parse tree based on the productions which you have seen before. So D is a declarative statement and it has a T and L or parent or child nodes. Since it's a float, we have to represent it by real. Then identifier 1, identifier 2, identifier 3. So ID1, ID2, ID3 all should be separated by comma. So the L comma L tends to identifier which is separated by comma. List of identifier L tends to ID which is separated by comma. L tends to ID, the last productions. L tends to ID and the third production separated by commas. So here the ID value, these are the first step, second step, third step. The number represented here is step, the order of evaluation. The first one, second. This is a dependency graph. The first one, how the information is flowing from one node to another node. This is dependency graph. First step is assigning the identifier 1 and the second identifier 2, which should be for and identifier 3. Fourth one is type. Its type is a float, that is real here, that is assigned to inherit, that is fifth step of L, and that is assigned to sixth one, identifier ID3, and seventh step, and its the type is assigned to eighth one, it's L, and its identifier, it's this ID2. And ninth one, L, its identifier is ID1, that is 10. Dependency graph. A dependency graph depicts the flow of information among attributes instances in a particular parse tree, which means how the information is flowing from a node to node. It may be a parent to child node or child to parent node or siblings. So for example, if we take this production, E tends to E1 plus T and its semantic rules with its attributes. So here this dotted line represents it's a parse tree, and the value represents the solid line represents a dependency graph, the flow of informations. Here E depends upon its value of E1 as well as a T. So the value of E1 is depends upon value of E1 as well as value of a T, which is the resultant value. This is called dependency graph. And this is a dependency graph for annotated parse tree. How the order of evaluation, which means how it is depending, how the flow of informations occur. Here the digit values, this is the first step. First we have to assign the all lower level, that is digit 1, since it is a it may be a bottom or top down approach. So if it is a synthesis, it should purely a bottom up approach. Inherited is a top-down and a top-down approach, since the children node get from its parent node. So digit value, this is the first step, assign value to this one, and this is the second step, assign value to this digit, and after that this is the third step, and this is the fourth step. Afterwards we have to assign the third value to its, since it is the inherited one, it's get value from the siblings. So assign, this is the fifth step, and this should be the sixth. These are the steps only. The flow of, this is not the value actually, these are the flow of informations from one node to another node. This is a dependency graph. Evaluation. Order of evaluation means how the steps occur, which means how we are evaluating. The first step, this should be the first step, and the third step, then we are assigning value here, the third one, order of evaluation. Then the fifth one, the value is assigned to this one, this is called order of evaluation. Dependency is how the nodes are depending to the other node, that is dependency. Order of evaluation is, this is how we are from left to right we are evaluating the expression. That this is called the topological sort of the dependency graph, decided the evaluation order in the parse tree. Thank you.